All right, good evening all. Today we're gonna go over the classification in R. So let me go ahead and start sharing my screen. So I'm gonna hit screen share. Oops. Okay, R Studio. Oops. Sorry. Now we're gonna go to R Studio. Okay, so here is R Studio. And what I'm gonna do is I'm gonna do a quick review of the classification of the decision tree method, and then I'm gonna do the perceptron. Guys, if you have your video on, would you please turn it off? If you have a web camera on, please turn it off because it's taking up the bandwidth. And if I need to pause to remind you to turn your video off, we're gonna cover less material. So please turn your video off. Please turn your video off because it's taking the bandwidth. Guys, I cannot continue until the video is off. Ooh. Can you turn your video off? Guys, if you have a web camera on, can you please turn it off?
I think it's Osvaldo who's probably got the video on.
Yes, because yes. Okay, thank you. Okay, so now let's go ahead and get started. What I'll do is I'm gonna do a quick review of the C3 implementation of the decision tree method, and then I'm gonna go to do the neural network. Now, so what we'll need to do is first we need to load our data, and there is more than one way to do it. We can just run the command, or what we could do is we could just use the tools, right here, tools, and we go import data set, right? And I'm gonna go from local file. No, this is from local file now, and what I did was I have a folder on my hard drive that I called the dataset, and I'm gonna find my file. I called it bank, and I'm gonna hit open. Now here, this is the name of the data frame or an object where the data is gonna be loaded. So I could keep it as is, but I'm gonna put a lowercase, right? Because RStudio is case sensitive, and I want to make sure I want to do all I can do to prevent errors, right? Now here is a preview. It's showing me what the data is in the input file like, right? And it's a comma delimited data because the file has a CSV extension. And here it's gonna show me it's a preview of the data frame, right? It's a preview of how the data is gonna look like, so to speak, when we load it. Now, so here I'm gonna keep heading yes, because my first row over here contains the table headings, right? And here is my data. So let me go ahead and click import. Now, what R did for me, it ran the command to load the data, and here is another command, the view. And what it did was it showed me the preview of my data set. Now, note here, I have an ID column, and before I run the analysis, I need to remove this column. Why? Because ID is not really related to what I'm trying to predict, right? And it slows down method performance as well. So now let's go over dependent variable and independent variable. Let's review this. A variable that I want to predict is a dependent variable. It's in classification problems, it's a class, right? So in the bank data set, my dependent variable is going to be if a person loan application was accepted or denied. The column name here is PEP, it's an abbreviation, right? So this is a dependent variable. The remaining variables are independent. And when I run the decision tree method here, right, so what I need to do is I need to remove the ID variable. So I'll quickly do this, right? I remove it, and if I want to validate if it in fact was removed, I can run the head command, right? Or what I could also do is I could run the view command again, right here. So notice this, here what I have is a script, right? I have all my code saved in a script, and in the top panel I can open up the file with a script, and in order to rerun the command that's in the script, I put my cursor on top of the command and I hit run. Okay, so now I see my variable was removed. Let me close this out. I'm gonna go back to my code, right? So this is a file, it's a file with R extension, and I wrote this file before the session. Now, what's happening is that if I'm working on my assignment in more than one setting, when I come back to it, I want to be able to reproduce the results, right? So what I need to do is I want to set seed. Basically, set seed is set sort of like the random number so that my results are reproducible. I pick the number 1, 2, 3, 4, but it does not matter. I just pick randomly. Run. Here what I'm doing is I'm dividing data in a test set and a training set. And the training set is part of the data that we use to build the model. And the test set is part of the data that we use to validate the model. Okay? So here it is. I'm going to run these 3 commands in here. 2, 3. Now, notice here, we need to make sure that test data and training data have the same number of variables, right? Here I see the number of instances in the train data and in the test data, but we want to make sure that the number of variables match. So if we need to do any data pre-processing, like removing variables or like discretization or anything like that, it needs to be done before we split data into test and training. And here what I did was I ran the function C3, and I store the result in the model. And the function takes, here is my data set, right, which is training data. And here, formula. Basically, formula, it identifies the dependent variables that I'm going to predict, tilde. And right after tilde, I'm going to put the list of my independent variables, right? Well, this is a wildcard. This is a wildcard. It means I want to take everything else besides PEP and make it as independent variable. Okay? So let me go ahead and hit run. Run. Oops. I see what happened. Now, what happened? I'm glad that I made this error. Because C3 is a method, right? This method does not come with the standard RStudio installation. It's part of the package, okay? It's part of the party package. What happened was on my RStudio, I already have this package installed. I already installed it, but the problem is when I load the RStudio, the package is not in the memory, right? So whenever you receive this error message, could not find a function, and you know that you already installed the package, it's because you have to load the package into memory. I can do it 2 ways. I can go here to the packages, and I can do this. I can scroll down, and I can find my C3 and I can check it, right? I can do that, but I'm sorry, I need to look for the party. Party? Yes, I would need to go through the list and check checkbox next to party. That's one way. Another way, I can just run the command. Right? There we go. So now what I see here, this is fine. some of you may think it's an error, but it's not an error message, okay? This is fine. It just tells me that the package was loaded. Okay. So now what I'm gonna do is I'm gonna try it again, and it's supposed to run right now. Okay? So what I need to do right now is store it in a variable called model, and I need to print the content of a variable to see my model. I have two options. I can run the print command, or I can just put model. There we go. So as you may remember, this is a textual representation of my tree, right? And I realize that it's very difficult to read, so what I could do is I'm gonna go back to this part later, but let me see, run. Okay, here it is. So very often it's harder to follow the textual representation than to actually see the plot. So what I'm gonna do right now, I'm gonna hit zoom. There we go. So now here is the tree for the bank data set, right? At the top, this is called the root node. The way we read this tree is this. I'm looking at the top. I'm starting from the top, income, and I'm gonna be asking a question. Is the individual income less than 29,625, something like that? Is an income less? If yes, I go to this branch. If not, I go to this branch, right? Okay, suppose that it's less. I'm here. My next question is, does the person have children? How many children? If the person has more than one child, then they are here, right? Then what will I need to do is I would have to look at this terminal node, and I would need to see which value is dominant, right? I would need to see which value is dominant, yes or no. So that's going to be the class of an instance, right? So this is how I read this. And this is how I interpret the tree, basically. So now suppose that I give you the completely new loan application, bank loan application. How do we use this tree to predict if the person's application will be accepted or rejected? This is what we need to look at. First of all, which variables here are significant, right? So we know income, we know children, right? Because those are the split variables. Income, children, married, mortgage, right? So what we need to do is, how do we determine the class of a new instance? We need to start from the top of the tree, right? And we need to say, is my income less than or greater than that number, right? Because this is a splitting criteria. And if I say less than, I continue here. Now, next question is about children, right? Suppose that I have 0 children, right? Then I take this branch right here. Now, it's asking me here if I have more than 0, which means I guess 1 in this case, or if I have just 0. If I have only one child, right, it's going to look again at my income, right? If I don't have any children, I'm going to go here, right? Then I keep going, and then until I get to the terminal node, I'm going to look in the terminal node, I'm going to look at the dominant value of a class. That's going to be a class of my instance. This is how you use this model, right? So let me close it out for a minute. And here is just another representation. Let me zoom in. Yeah, it's just another way to represent this tree. And here it's just showing me the percentages. The percentage of instances in this node that are classified as yes and classified as no. Okay? So that's what it's doing here. And this is just another representation of the same tree. Let me close this out. So let's go back here to the part that we skipped. Now, here was nothing but the textual representation of a tree, and here it gave us dependent variable, all of the independent variables. And this one is just basically telling me, okay, I'm looking at the income, and here is the next node, right? This is children less than 1, right? Node 2, and here is a node 3. So that's basically same information, but just in a textual format. And the star means it's a terminal node. Terminal node is also called the leaf node. Okay? So now what I want to do is I want to check how accurate are my predictions, and this is going to build the confusion matrix. I run, right? So the confusion matrix, it's showing me the actual class versus predicted class. So how many applications were actually accepted versus how many applications were predicted to be accepted, so to speak. So basically, in order to find out the classification accuracy, we're going to add the numbers on this diagonal, right? So we know is 221 plus 140, right? So we know that 121 applications that were actually rejected were classified as rejected, and 140 that were classified as accepted are actually accepted. Now we can use R as a calculator, right? So here is the sum of numbers in the diagonal, and to get the accuracy, I would just divide this number by the number of instances in a training set, which is 416, right? Yes, I would have to type this 361 divided by 416. There we go. So here's about 87%, right? And then your next step would be to reevaluate the model on test data. So here it is, predict command, and new equals test data. I rerun it, and then I'm going to run it again to get my confusion matrix, right? And the numbers are smaller because my test data is only 30% of the data set, right? And to calculate the accuracy, I would add these two numbers and divide it by the sum. But it's completely acceptable to see the classification accuracy lower for the test set than for the training set. Okay? So now something else to keep in mind, that the decision tree method, it predicts the class. There is a class. Okay? There is a dependent variable and there is a class. While the association rules that we looked at earlier, there is no class, there is no dependent variable, right? Although you could restrict the rules to, you could limit the rules to show the items for specific variable on the right-hand side. There is no class. Here in the decision tree, we have a class variable, right? So now what we're going to do is we're going to start looking at the neural networks, and I'm going to start. There are several three difficulty levels of this problem. I'm going to start at the lowest level difficulty, right? First of all, you need to install the package called neural net. There is more than one application of there is more than one implementation of neural network in R, but I'm going to be using the neural net package. If you have not installed it, then you need to run it. You're probably going to need to run it on the first time, right? Since I already have it installed, I'm going to skip it. Now here, library command is it's gonna load the package into memory. This is important. Every time when you restart the R session, you have to load the package into memory if you're going to use it. Run. There we go. Now, here, notice this line right here is a comment. And the reason I put comment is that because suppose that I want another developer to edit my code and the other developer needs to know what I'm doing, right? Okay, so here I'm gonna be using a different data set called diabetes, and I can go ahead and I can use the interface here. I can use to load the data, or I can alternatively I can just write the command. But if I give you a copy of this script, keep in mind that this is a file location, and your file location is going to be different, right? Because it depends on which folder you save the file in your hard drive. Okay, so I'm going to go ahead and run this, and I'm going to run the view to preview. Here is my data in the tabular format. Now, why I'm saying that it's not easy, but the easiest level of the problem is because I have my dependent variable, which is the values are 1 or 0, right? And I have my independent variables, which are numeric. I don't have any categorical variables, so no problem. And I have the class values are 1 and 0, right? I have only 2 possible class values, so that makes it much easier in this case. So, and the values are just 1 and 0. Now what I'll do is I'm gonna keep this as numeric, very important. I'm not gonna convert it to a factor, and you're gonna see the reason shortly. So let me close this, and I'm going to go back here. Now, what I'll do is we have to run the setSeed command. It's related to certain steps in the method using random numbers. So if I started working on my homework assignment and I need to stop in the middle of it, right? Since assignment is big, it cannot be done in one sitting, and I want to be able to reproduce my results when I get back, right? I want to run setSeed. That basically makes result reproducible, and I just pick the number, any number. Right, so now what I'm gonna do is I'm going to build my model. Here you may notice that the structure is a little bit similar. You specify your formula and you specify the dataset name and hidden number of hidden layers. I'm going to explain it to you. Number of hidden nodes and a hidden layer, rather. I'm going to explain it to you. But one thing to notice here is that we were very spoiled in the last exercise where we could just go ahead and put a wildcard, right? If we wanted to use all variables, we have one dependent variable, but if we wanted to use all remaining variables as independent, we got really spoiled. We can just put dot. Nope, we no longer can do it. For this exercise, we no longer can use the wildcard because neural net function does not take wildcards. Unfortunately, we need to type all variable names right here, like I'm doing, right? Well, what I could do is I could define formula as a separate variable and put it here. I could do that too, but I did it this way here. Now, another thing is that I call it patience is a virtue when running neural network, because very often you might get an error message that says it did not converge. If it happens, you just try again. Here is a little bit of trial and error. So let me run this command, and I'm going to store my network in a variable called NN, right? Let me run this. See that it takes some time to run? Well, usually it just runs quickly. Sometimes it may take a while. And what's going to actually happen is it's highly possible that you may get a message that it did not converge. Then you try again. Okay. Now, while it's running, what I wanted to tell you is that if you're using neural network methods, it's very important to make sure that your data set does not have a unique identifier, because it really may kill the algorithm. Neural network takes memory to run. So make sure that unique identifier is removed, right? Just something to keep in mind. See this? If you get this error message, I'm sure that you will, what you do is you just try rerunning the command again. And since I'm really lazy typing this, what I could do is I could hit the up arrow, and it's gonna, and then hit enter. This is just a shortcut to rerun the command you ran before. And let's see if we're lucky this time. If not, then we have to try the different... Oh, there we go, it worked. So this is a patience game. Okay, so now what we'll do is, I'm gonna go over this, but I think first it's easier to visualize, so that way you're gonna see what I'm talking about, right? Let me see, run. There we go. So here it is. This is how my network looks like. Here are all my input variables, and here is the output variable. But basically, let's look at this piece right here as a box. We don't know what's in it, right? We look at the details later. Here, input, right? Input. Here is some function, and here is an output, right? That's how you want to look at it. Now we go deeper in the details. What is this? This is hidden node, right? Remember I had a hidden parameter? If I go back here, I had hidden 2, right? So that tells me that I want my network to have 2 nodes in here. Input nodes, output, and in here, those are hidden. I can have more than one layer. In this case, I just have one hidden layer, 2 nodes. Now, notice that here, every node in the input layer is connected to every node in the hidden layer, and every node in the hidden layer is connected to the output node, right? So this is another difference between the decision tree, because in here, you've got layers. The nodes in the same layer are not connected, right? But every single node in a output layer is connected to each node in a hidden layer. It's interconnected. Now, also notice each line has a weight, right? And here is the intercept. So every node can be seen as a function, right? Which takes all of this as an input and produces this as an output, right? Okay, so now, if I tell you that I have this, in this data set, this is diabetes data set, right? And it's a patient data. Suppose that I give you a record for the new patient, completely new. We don't know if the patient has a diabetes, but I want you to use this model to predict if a person has a diabetes. What are we gonna do? We're gonna plug in our inputs, right here. We're gonna just take the inputs, plug it in, and we get the output. The output from this network, right, is gonna be a decision. It's gonna be a prediction, rather, if a person has a diabetes. Think about it as a black box, so to speak, right? We don't know what's in there, but it's like any function. When you have a function and you have an input, you can put that input, you could plug it into the function to get the output. So basically, that's what it means. When I ask you, how do you use a model to classify the new instance, you just take the independent variables and plug it in, and you get your value. That's all. Now here, this is a number of steps, right? So if you read in your homework readings, this is a backpropagation method, right? So the process is iterative. It shows me the number of iterations that the method had to go through until the weights are finalized. And basically the error, it converges. After each repetition, this error right here converges. Now, let me close this and let's look at the other properties here. So, names command is going to show you which properties are available for the network, right? So, for example, call call is gonna show me which command I ran to build the network, right? It shows me the command that I ran to build the network. And here it is hidden, right? Equals to. That's how I got two nodes on a hidden layer, right? One layer, two nodes. Now, if I wanted to do two layers, this is how I would do this. Let me copy this. Control C. Control V. Oops. I did not really copy. Okay, so let me. Anyway, if I wanted to do, if I wanted to do two nodes, so let me go up. Here we go. So now, if I want to do more than one layer, the way I would have to do it, as a list. See? And here I'm gonna put. Come on. So here I would have to put this 2, for instance 1, right? What this will do is it will create a neural network with 2 hidden layers, and it's gonna be 2 nodes in one layer, in the first layer, and 1 node in the second layer. Let me see. Looks like it ran. So let me run the plot command and see what happens. There we go. Alright? See the difference? Do you see the difference? So here, what I did was I specified I wanted to have 2 hidden layers. So what I did was hidden equals C. C is a list, and I put 2, 1. It means that I want in the first layer, I want to have 2 nodes, and the next layer I want to have 1 node. And this is the output, right? So I can change the number of hidden layers and the number of nodes in a hidden layer, right? That's what I can do. If I ask you, for instance, run the method with different input parameters, you can try different number of nodes in a layer or different number of layers, okay? Now, so this is sort of like a trial and error, and then you can compare the error, and you can compare the number of steps that the method took, right? So I'm gonna close this out. Here I just showed you other properties that you could look at. For example, response. This is going to be the variable that we are predicting, right? And what you could also do, here this one is the model, but this is gonna just show you. This is just gonna show you the independent variables and dependent variables. It's not gonna show you the actual picture of a model, so to speak. Oh, now I want to show you the difference. Weights right here. These are the weights after the last method iteration. So if you look at these numbers here, and if you look at the visualization, oops, I'll have to run the plot command again. Okay, plot. There we go. So if you look at these numbers here, see this? This is the last one. Right, last one, and if you compare it, this number right here is the same as the number right here. So this shows me the weight, right? So here it is. Look at this. This is the output node, and I see the intercept, and here this is the weight coming from the last hidden layer into this node, right? Negative number. And here, see this piece right here? Those are the weight for this hidden layer, and so on, right? If I look up here, I'm gonna see information for each input node, right? Yeah. So this weight right here, the listed rare. Okay? Now, another thing to keep in mind in here is that those are the final weights, the weight after the last method iteration. There is also initial set of weights, right? Start weights rather. Those are the weights after the first iteration, right? The method runs for several number of steps until the squared error converges. Error is the difference between the actual class and the predicted class. So that difference has to get significantly. It has to converge to a certain number, so to speak, right? And that's when the method stops. And so when you do the comparison, you want to look at the confusion matrix, the accuracy. You want to look at the error, and you want also to look at the number of steps the method took to run. Now what we're gonna do is how can we select? How do we get the predicted values? This is how we do that. We use compute command, right? Here is the command, run. Oh, okay. So what we did right now is here we did the predicted class and we store it in a variable which are called myPredict, right? And if I type this, what it did was this actually it just showing me the number, right? But I'm not interested in this. I need to actually see if somebody, if an individual has a diabetes or not. And actually, this is not what I want. Let me rerun my initial command with the 2 nodes, because this is not what I want. Here we go. So now, let me see. And the reason is because I'm not doing, in this problem, I'm not doing the prediction, I'm doing the classification, so I don't expect these values to be the same. So let me see. Let me run this now. myPredict. Run. Okay, so now let's run myPredict again. Here we go. This is what I want. Not good. Not good. Anyway. Oh, yeah, because I had to run this first. Sorry, guys, about this. And now I do this. I round it. Here we go. And now I do the confusion matrix. Oops, I did something wrong. Oh, because I forgot to set the linear output equals false. That's what I did wrong. I thought it was okay. Let's do this. Let's run this again. There we go. So sometimes it's a little bit of the trial and error. Yeah. So basically what my output is going to look like is I'm going to get the predicted values are going to be the probabilities. They're rather going to be the probabilities that an individual has a diabetes. And what I'm going to need to do is here, I'm going to need to round them to the whole number, right? So if the probability is 0.4 perhaps, then the person does not have a diabetes. And after that, I'm just going to build my confusion matrix to see how many instances were classified correctly and how many were misclassified. This is a little bit similar to what you did in the decision tree exercise. Okay, so that's a little bit of patience game here. Okay, so now let's do it again. Run. Okay. Run. Oops. Still same. So I have to look into it, because this is not really what I want. I expect to have basically what's supposed to happen is that the values should be the probability, not the single number. So I have to look into it, but but you got the idea, right? So here is the method, right? That's how you call it. You would need to type all the variable names. Now, names command is going to give you the available properties, right? So let's see what this does. This shows you the predicted values. So see that this is not good because I'm not supposed to be seeing the numbers. I'm supposed to be seeing the probabilities. So for some reason, yeah. And then you should be running this to do the confusion matrix. But for some reason, today is, yeah. I would have to play with it. Okay, or I could also change the number of hidden layers and so on. Now, but you got the idea. So this is the first level. It's the first level of difficulty. Now we're gonna go a little bit level higher, and I'm gonna look at the bank data that we just looked at. And the problem here is that I have variables. I have my dependent variables that are numeric. I mean non-numeric, categorical. I have categorical variables. And if I go ahead and just run the method as is, it's not going to work. Because for my variables cannot be categorical. They should be either numeric or binary. But what if I have a categorical variable? There is a step that I need to do. And each categorical variable will be converted to a set of dummy variables. And the way it's gonna be is, let's run the summary command on bank data to show you. Bank. Okay. See this? Like for example, I have sex, right? Male and female. It's gonna pick one of the values, and it's going to create a variable, and it's probably going to name it as sex prefix with female or male, whatever it picks, because here is a tie. Usually it picks the one with the dominant number of instances. And it's going to say the value is going to be 1. For instance, that if the variable name is sex female, the value is going to be 1 if the sex is a female, and it's going to be 0 if it's a male. Same thing it's going to do for region, but here I have 4 values. So this variable needs to be converted into the 3 variables, right? Yes, it's going to be converted into the 3 variables, right? 3 dominant values. I'll show you what will happen. So this is a step that you would need to run. I know that this part did not need to be done on the first example that I showed you, right? But this is one level higher, right? So this is a medium level. Let me run this here. Now here, I forgot to say that this is a bank data set. We already loaded the data, and I already removed the missing variable. I mean, not missing variable, I'm sorry, the ID variable. I already removed the ID variable. One way to do it is just set it to null. That's what I did. And here, let me run. I already ran it. I don't need to run it again. Now, I'm going to create this matrix. Run. Okay, and I'm going to show you what it looks like. Matrix train. So to see it, I have to run the view command. Okay, there we go. Okay. Oh, I see. It's because, you know why? Because it's case sensitive. The V has to be uppercase. There we go. Yeah. So now this is what it did. Look at this. It took my sex variable, and for some reason it picked male. And what it did was, if a person is not a male, the value is 0. If a person is a male, the value is 1. For the region, remember, here I had 4 values. What it did was it picked 3 out of 4 with the most dominant values, and it created a separate variable for each one, right? Yeah. I see it yes. And what it did was, if the value, for instance, is town, right? If the value is not a town, then it's 0. If the value is town, then it's 1. And also, if you look at 3 values, if all 3 of them are 0, then it's a value that was not picked. Yeah. So now, good news. The good news is that I only had one. My dependent variable has only one value, right? It's just one. I'm very lucky. I don't need to do much because it's just one. It's either yes or no, right? There is nothing. It's not as complicated as the issue as the example that I'm going to show you next. But here I only needed to decompose my categorical variables in independent, right? Independent categorical variables. I did not need to do anything special for dependent. Okay, let me close this. So now to run the method, I'm not going to use the original data set. I'm going to use the matrix. Right, I'm going to run this there now. Run. Okay, it's taking its time. And I'm storing it in a variable NN. And I'm going to visualize this. But here the idea is that if you need to look at your data types of the independent and dependent variable. Dependent variable has only 2 class values, which means I'm lucky. And I look at my independent variables. If there is a categorical variable, then you cannot run the method on the dataset as is. You need to do this matrix. You have to build the matrix. Okay. Again. If this does not work, then I would have to try different number. Okay, it worked. See this? So it's a matter of trial and error again. So now what you could do is do this, and let's see, my predict round. Let's see if yes, it worked this time. It worked this time. Okay, so let me explain to you what I did here. Here I'm just building my network, right? And everything is the same formula. And here, it's no longer a PAP, it's PAP yes, because I'm using my matrix, right? That's a variable name in the matrix. What it usually does is it picks the original variable name and puts a suffix, right? Here are all my independent variables, and for some reason I just throw away the income. Okay? So sometimes if it does not work with all variables, you start taking them out and adding them back in until you figure out which variable makes it not work, so to speak. Sometimes it's trial and error. Here is the data that I use in an input, and here is the number of hidden layers too, right? I mean number of nodes in the hidden variable, sorry. In the hidden layer. Number of nodes in the hidden layer. Okay, here it is. So now I could, here what I'm doing is that this is to get the predicted values. Compute, and this is just the syntax. Okay, let's think about it this way, just the syntax. Here, because if I look at these values, my predict right here, my predict. Yep. See this? After I round it, I need to see 1 and 0. That's what I want to see. Because see here, when I run this command, and then I run my prediction. It looks like this. It looks like percentages. See this? Basically what it does is it predicts the percentage. What's chance that an individual has a diabetes? And if the chance is 0.5 or above, then an individual has a diabetes. Here apply function is just going to round, right? It's round to the whole number. That's what I'm doing here. And here I'm building the confusion matrix. So here are the predicted values, and the actual values, I'm just taking the last column of the matrix, right? Because remember, the last column in the matrix was the actual value. Yeah. So because if I run this command again, view, and then it's elicits. Yep. It's yeah, something like it's no, not train data. Well, if I run this command again to see my matrix, right? Oh, it's a matrix. It's a matrix train. Sorry. Okay, if I run this command again, see this? Here it is, right? So that's variable number 14, 14's position. I can do it more than one way. I could specify the position. All right. So let me go back. Here it is. So here it just showed me the confusion matrix. Oops. See this? It does not look so nice. So what I had to do is I had to do the rounding. Otherwise, I was not getting the result I wanted. Here it is. So here, and the way I would do this to calculate the accuracy, I would do this. I would use this as a calculator, 260 plus 192, right? And then I would need to divide it by the total number of records, right? And I'm looking right now at the bank data, which is 600, right? So 452 divided by 600, right? So this is the accuracy. Now here I did not divide the data into training and test set, but I don't want you to get this misconception. Yes, in theory you would want to run it on a training data and then on the test data, but I simplified it because the neural network, I found it the hardest method, but trust me, sometimes you may want to set aside a little bit more time for this assignment because it's a matter of trial and error. Yeah. So here, this is a medium difficulty level. Now, are you ready for advanced? Yes or yes? Okay, now let's look at the advanced one, and it's here. Here we're going to be looking at the cars data, and let me read this. Ooh, cannot. Okay, I see what the problem is. It's because I have to set the working directory first, and now I have to read this. Okay, now there we go. Now remember, I can load my data from here, tools, import data set from local file, or if I already loaded the data, I could just copy and paste the command. I could just save the command and then run it again next time. But here the problem is I did not specify the full path to the file. So rsync, the file is in my currently set working directory, right? Remember, working directory is a folder where R looks by default. If I want to open a file, that's a folder where it's going to look at first, right? So now let's look at the cars, the first 10 rows. Here it is. Now look at this. The dependent variable is symbol in. It stands for the car risk level, and there is more than one value. There is more than one, so what I'll need to do is I'll have to decompose it into a set of dummy variables. And the problem I have now is that I have independent variables, right, which are categorical, and a dependent variable has more than one value, right? It has more than one So I'm having a problem here, right? If I run a method, I'm gonna get an error. But before we do anything, we have some data preprocessing to do as well. Why? Because we have a unique identifier here, right? Neural network method does not like unique identifiers. That's something to remember. Plus, we have two variables with missing values. We need to handle the missing values. HP variable. But how do we know that? First of all, one way to know that is you run a summary command and you look at the results here. Now, how do I know that this is a unique identifier? Well, because you look at it. Well, you're gonna look at this. See this? You just need to look at you can look at the preview or you can do the count. Well, there's more than one way to look at it. But see this? We have the cars data set has 205 observations, right? It's sort of kind of like you're gonna see it starts the lowest value is 1, the highest value is 205. If you see something like that, you may start clicking. Yeah. So this unique identifier, we want to remove it, right? So that's something to remember. Neural network don't like unique identifiers, and you want to handle the missing values. And the way we're gonna do it in this case, we're gonna replace it with the mean, right? So now remember what NARM equals true, right? It tells to compute the mean value, but ignore missing values. Right? If I just run the mean command, and if there is a missing value, it's gonna give an error. So let me go ahead and run these two commands first. And here I'm just gonna remove the ID. And here, the last variable, oh, I see what went wrong in the first example. Because I had to change the variable to the. Okay, I see. Anyway, let's do it correctly right now. Here it is, car symboling, right? What I'll need to do is I have to change it to a factor. And the reason I need to change it to a factor is because I'm not doing the prediction problem. I don't want to see something like 1.5 for the car risk level. I want to see if the risk level is 1 or 2 or 3 and so on. So what I'm gonna do right now is I'm gonna run this here, run. Okay. Now what I'm gonna do is I'm gonna do set seed again. Right. My next step is to build the matrix, right? Why do I need to build the matrix here? Because I have factor variables, right? In the very first example that I showed you, nothing, we do not have to worry about it. Although it would not hurt to do it, but we did not have to do it. Now here, what we'll do, let's run this thing, and let's see what's happening. Here we go. See what it did? A car make, it created a separate variable for almost every value of the car make variable. And then we're looking at the very first row. And for each make, it's gonna check, for instance, if the make is Toyota, then it's gonna put 1. If the make is not Toyota, then it's gonna be 0. See this? Each value becomes a separate variable. Fuel type is decomposed. If the fuel type is gas, value is 1. If it's not gas, it's going to be 0. Same thing happened to the number of doors. So far we are good. But let's scroll down. Aha! What happened to my symboling? Why did I say it's advanced problem right now? Because I have more than one dependent variable, right? I have more than one dependent variable. Here, what it says that if the car risk level is true, then right here, this is 1, right? The second instance car risk level is 3, so here is 1. If I see all zeros, it means that it's a value that it did not pick, right? Because it picks only the dominant values, right? Now, here there is a problem. In this column name has a problem because it's a symbol in -1. Notice this column name. This is a problem because when I first ran this, I was getting an error message, and then I realized that it did not like the -1 in the number because it was thinking that I'm doing the subtraction. So what I had to do is I had to run a command to rename this. Yes, I did that. And I'll show you. Let me close this. Oh, this one. I just say this. This just does nothing but just changes the column name. I'm just saying if the column name in the matrix is this, change it here. Okay? But to be proactive, I would want to make sure that the categorical variable does not have negative value, nothing like that. Because my variable name is going to be suffixed with the value. But, well, I just renamed it and it solved the issue. Now, here, to run the function, look at this piece right here. What is this? Before, I had one independent variable. Here, one dependent variable. Here, I'm going to list all of them, right? Because it's no longer a single variable, it's a set of dummy variables. And here, I just put the dependent variables that I want to use. I'm not using all of them. And I did a little bit of trial and error, and this is a combination that worked. And linear output equals false. Okay, this is important because I don't want to predict the numerical value. So now let's run this. I did not run it, right? Run. And then let's run this. Oh, it's running now, yeah. But something very interesting here is that this network is going to have more than one output node. Unfortunately, RStudio does not have a built-in visualization function to support the more than one output nodes. That what I had to do is I have to run a script from the GitHub, and the code is here. Okay, this is a script that we would need to run to be able to visualize the model. But before that, I would have to install a package. If I have not already, I would have to install a package called Developer Tools. Alright, it's a library, and I would have to load it into memory. Well, let me show you what it's going to be like. Let me show you what it's going to look like. Here. So I already have it installed. I don't need to run it, but I'm going to load this library into memory. Now here, this is going to run this script. And you have to run it each time. If you restart the R session, right, and if you need to plot this network, you'll have to run this script. Run. Okay, and this is a message, it's not an error. So now I'm going to do plot. Here it is, right? So this image, you may have seen it, some of you may have seen it in the assignment description. So this is how you do it. You have to run the script located on the GitHub to build the network with more than one output node. So here is my input, right? City miles per gallon, highways miles per gallon, agent size, fuel type, number of doors, right? And here it's basically saying if the number of doors is 4, the input is 1. If the number of doors is not 4, input is 0. Here is my hidden layer, and every node in the input layer is connected to the hidden layer, right? And here are going to be the probability. The output here is going to be the probability that the car risk level is -1, well, I just rename it to M1, which stands for -1. And this is 0, 1, 2, and 3, right? So what I'm going to do in order to determine the actual risk level, I'm going to pick the highest probability, right? It's going to be an output with the node with the highest probability. So this is a little bit different. And the reason I classified this problem as advanced is because you have to decompose the dependent variable in dependent variables, and you have to do this extra step to do visualization, and even more. Okay, so let me close this out. So here is basically how you see the properties, like call. Call is the command I ran to build the model, and you can get the weights, the starting weight, weights after the last iteration, and I think net result is going to show you the weights and the error. Yep. Oops. Okay, so this is the weight. Okay, so weights, again, we can look at it and we can compare. Right, we can look at the, oops, that's not the right one. We can look at the plot that we just did, and we can compare the numbers. Plot, and here we go. So see this, each of this is an output node. I have 5 output nodes, and you can look at this weight right here on the blue line. It's right here, right? It's just different representation, but it's much easier to read right here. So see, this is the blue line. This is an intercept, right? And the book calls it sort of like, to speak like a little noise, something like that. Noise in a function. Because what it does here is sort of like a sum of this intercept plus this number multiplied by the input from this node here. Output from this node, sorry, output. Right? Then it's also looking at the output from this node and this number, right? So see this, it's an interconnected. Every node in a layer is connected to every node in the next layer. So here are my weights and so on. But one thing here to keep in mind is that the confusion matrix. To do this, it's actually extra step. So first step, of course, is to do my predictions, the way I did it there. Now what I did was, I had to do a little bit of research, and I had to find a function which will find which output has the highest probability. So what I did was, it just built a function, and then I apply this function to this set. So let me show you what this will do. First, run. And now I'm gonna type, I want to see what it looks like, of course. Wait, let me see. This is what it looks like. Oops, it's very difficult to see because I have 5 nodes, right? What this is going to do is, it will show me the probabilities for all 5 nodes. And see how it is, E times 0, 3. Well, it's just a notation. But what I need to know is, I need to know which output node has the highest probability. So what I had to do is, I had to do a little bit of research, and I found the way to do it. I have to create a function here, and then I need to apply the function. And here it gets index. Here that it returns me, it just tells me which node has the highest probability, right? And then I'm just applying this. Let me run this. So that's the reason I say this is an advanced, because you have to do extra steps here. There we go. Right? So this shows me the predicted risk level versus actual risk level, something like that. Yeah. Well, I know that my numbering is off a little bit, but I would have to look into this. But you got the idea, right? The idea here is that you have more than one output node, and you're gonna be looking at the node. You're gonna be looking at the output node that has the highest probability. So that's gonna be the class, right? And then you're gonna do the confusion matrix, right, to determine the classification accuracy. So this is advanced. And if you're in DBST 667 session, this week you have required exercise. So required, it means that you need to do it for grading. And if it says recommended, so don't get me wrong, recommended does not mean that you don't need to do it. No, recommended means that you don't need to turn it in, but you still need to do it because it will help you with your big course assignment, and also it will help you get better understanding of the topic, because I don't want you to get a misconception that this method only works if the output variable is binary, which it's not the case. I just showed that it's possible to make it work if your output variable, right, has more than one class value. It's possible, but it just took a little bit of researching the other developers' code on the GitHub and finding the solution. So that's the reason I believe the neural network is one of the most challenging methods that we're going to study in this course, because it took a little bit of research, and because, again, it does not take the wildcard. You have to physically sit and type all the variable names, right? So that's one reason. And also because it does not decompose the categorical variables for me, right? I'm sorry, did we have a question? Did we have a question? No? Okay. So, basically, yeah. So basically, that's what I was saying, 3 difficulty levels, and I'm going to post the script in a classroom. I'm going to give you a copy of the script for this and for, yeah. So this one is part of the required, I think, yes. Because basically required assignment, it has 2 parts. The first idea is for you to do the walkthrough, right, and learn from it. And then the second part, you use another data set and do it for grading. And the reason the assigned data set for this week is this time is different. It's because when I assign the data set for an exercise, I try to pick one that's really meant for that exercise, because my goal is to make sure that you first understand how to use the method. But the fact if the method will work on a data set, that's the next step. The first step is to learn the basic idea of how the method works and just get familiar with the concept. Later on, we're going to be building on it, right? So hopefully right now you're going to have an idea of the differences between decision tree and a neural network, right? And hopefully you understand the difference between the association rules that we did earlier and the classification, right? And later in the course we're going to introduce prediction, right? So just a quick overview. Classification predicts the class, right? The categorical value. While prediction is going to predict the continuous value. Like, for example, predict somebody's salary, it's a continuous number, right? Predict somebody's body fat percentage, or predict the house value, that's a prediction. So you could use neural network, or we're going to do regression later on, okay? But this is a classification, right? So we predict the class. The class is a specific value. So when your dependent variable has a predefined set of values, like a car risk level, right? There is a set of risk level 1, risk level 2, risk level 3. There is no 100, and we know the number of risk levels. It's fixed, right? The values are fixed. Yeah. So now let me see what questions we have. I know I talk a lot today. I get really excited about our stuff. I want you guys to ask questions because it helps everybody. Yes, go ahead. Go ahead. Yeah, just unmute yourself and speak. I cannot hear you. Did anybody have a question? I cannot hear anybody. Let me see. Guys, I cannot hear anybody. I thought somebody raised their hands. Can you hear me? Yeah, can you speak? Can you speak? Okay. In the beginning, you mentioned. Oh, okay. I see. Okay, let me answer it. In the last homework assignment, I asked how we use the classification tree to classify the new instance. This was a very challenging question to everyone. And some of you thought that you need to go and change the data frame. No, you don't need to change the data frame. Let me see, this is still my tree, right? If I ask you, how do I use my model to classify the new instance, right? What is a new instance? In this case, my new instance is gonna be it's a bank, right? The bank data. I want to know if an individual's application will be approved and rejected. Okay? So what I would need to do is I would need to traverse the tree. I would need to come to this node right here, and I would need to look at the person's income. Does the person earn less than 29,000, something like that? Yes or no? No. Then I go here, right? And then I keep traversing my tree until I land into the terminal node. When I am at the terminal node, I'm gonna look, what class is dominant in that node? And that's gonna be the class of my instance, right? So you want to look at it yeah. What is it? Deal with imbalance? Oh, you mean imbalance data? Well, I would need to look at the specific scenario, because the thing is, there is no right or wrong, so to speak. But if you mean imbalanced data where you have in the training, it's highly possible that you may have the values in the training set that are not in the test set, and vice versa. You would need to look specifically at the data set. Sometimes, if the values are least dominant, you can group them. Again, it's a data set per data set scenario. Well, the question was how to deal with imbalanced data for classification scenario in a training data set. Yeah, one way would be to group the values, but again, there is no, so to speak, prescription. You would have to look at the data first to see how you deal with it. And sometimes it could be trial and error. So, and on some homework assignment, if you're in DBST 667, you notice the last question, I'm asking what's the most challenging part of the exercise and how you resolve the challenge. And one reason for asking is that, suppose that you run into a challenge, right? So what you do is you document the solution. So later on, if you run into the same problem again, you can go back to your notes for the assignment and you have a solution. So it's highly possible that you may run into it again. Yeah. What is this? Huh? Oh, well, that's a good question. Okay, I will need to look into it. I will need to look into it because... Oh, Joe? No, I did not ask this. I did not ask this question in the 650. I asked this question in DBST 667. I asked that question. Oh, but for using the model to predict the new instance, that was in the DBST 667 class. Yeah. But I'm not sure what it mean. What do you mean by R imbalance? I'm not sure what you mean. I would have to check. Oh, I would have to look at it. Yeah, I would have to look into this. I'm not sure what it means. Okay. I'm not really sure what the question is. I'll have to look into it. Okay. So let's see. What questions do we have? I want you guys to ask questions. Guys, now it's a good time to ask questions. I would have to look into the imbalanced training set. Okay, I would have to look at the imbalanced part. Yeah.
Will you provide the data
Yes.
set,
Yes.
like
Mhm.
recommendations for which type of data?
I'm sorry. What's the question? I'm sorry. Can you speak? I don't hear you. Guys, what was the question? Can you speak? Do you guys hear me? Guys, do you hear me?
That
You're breaking off.
like us to use, or
Huh? I'm sorry, you're breaking off. Can you speak? Can you say the question? You're breaking off. I don't hear you.
oh, I was wondering, are you going to provide recommendations for which data sets that you would like us to use, or should we just continue to use the web link that was provided in the content area?
Oh, it depends on which session you're on. Which session are you on?
This week's.
Oh, are you in a DBST or in a data?
I'm not understanding.
Are you in DBST 667 or in data 630?
6:30.
Oh, okay. Okay. Linesh?
Yes, Elena?
Yes, she asking about the data, something about the data. Because...
So, okay, could you please repeat the question? I'm sorry.
Yes, yeah, I was asking, Yelena mentioned that, that she was using this data set, but I was wondering if you have any specific recommendations for which data set to use with this particular assignment.
Oh, so are you part of the 2165 section in Virgis and Ashraf's class?
I'm in Body's class.
Oh, okay. So not sure here, Yelena.
Well,
that's okay. I can always email him and ask.
Yeah. Maybe you want to email him because I can probably help with that if it is from Ashraf's class. It's the section 2165 that I can probably
Mm-hmm.
I don't want to kind of say something for, the class that, and I'm not part of.
Yes, I understand. Thank you.
Mm-hmm.
Yeah. Oh, okay, I see. Well, because what we did was we have a meeting. That way it's much easier because data mining is in both. It's in data analytics program and it's in a database program and data analytics. And I'm a TA in both programs, guys. In case well, just to give you a little bit of introduction of myself, I've been a teaching assistant for about 7.5 years now, and I'm in database and in data analytics program. So that's why, just to resolve the confusion a little bit. Yeah. So I'm gonna look into the imbalance question because I'm not even sure what it means, but I'm gonna look at it. What is you mentioned? You mentioned something about, oh, the association rules. Well, yes, I mentioned something about the association rules. Well, it's because if you're in DBST 667, the third week of class we did the a priori rules, but I think I have an example right here. So basically, well, I can go ahead and show you. About this. So here is the data set is a credit approval data that tracks if an individual's credit card application is approved or denied. I can do this. I can run this thing here, right? And I can run this to preview my data, right? So here are my variables. And what's interesting about this data set is that they don't tell you the variable names. It's just because they want to keep the data privacy. And over here is a class variable, right? This is a dependent variable, and it tells if an individual credit card application was accepted or rejected. And the first 15 variables, you can look at them as application fields, so to speak, right? Let me close this. Now, association rules method just finds sort of like patterns in the data. The problem is the method requires all variables to be categorical, and they cannot have missing values. So first of all, what you need to do is you need to install these two packages. A rules, that's a package to build the rules. And here, this package is to visualize the rules, right? So since I already installed, I just didn't do run. Okay, here, this is the data pre-processing steps. What I'm doing is I'm replacing the missing values with the mean, right? And I'm running the discretization. Discretization is gonna convert my continuous variable into the nominal variable. Another word for this is binning, right? So if you notice here, right now, some of my variables here, they have numbers, right? But a priori rules, it's not going to work. Association rules is not going to work. I need to have number ranges here instead of numbers. So what I'll have to do is I'll have to run the discretization method. And the method is implemented inside the rules package. It's inside the rules. And discretize, and the method here, I have a choice. When I specify the frequency option, it means that I want to have approximately the same number of values in each bin, right? And I just picked 6. I just did it. It's just because I just decided. Okay, now what I do is I'm gonna create my rules. First, I'm just gonna use default. I'm not gonna specify any parameters. And okay, here is the output, and it shows me how many rules I got generated, right? And it shows me the minimum support. So basically, it says that the rule needs to occur at least certain number of times to be listed, right? And this is what I meant by here. I hit run. Okay, and I hit inspect rules. This is what a priori method is. So basically here, see this? It says if there is no class, right? I have a left-hand side and I have a right-hand side. And basically what it's saying here is that left-hand side, if A11 equals 1, A13 is G. And I'm looking at the metric, right? And support and confidence mostly look at how frequent the rule is, where leaf does not, right? And yes, there was one of the questions, if in DBST 667, there was one of the questions that a lot of you did not get right, and I'm going to tell you the answer. For the a priori rules, why do we consider more than one metric? Because support and confidence, I look at the most frequent rules. They overlook the least frequent rules, so it might be interesting. Then, support and confidence metric, they do not consider if the left-hand side and right-hand side are independent, right? They don't consider the correlation between left and right-hand side, right? On the other hand, lift does not work well for comparison when the rules have different lengths. And the length means the number of the item sets. Like here, you don't really see the difference because you only see one item on each side. But I would need to see more, I would need to do more rules here to see this. I can do this. See this? I can do this. I can run more. I can get more. I can display more item sets. Yeah. But see here, I don't have that much variation. But if the length, if I have, for instance, one item set length 1, another one I have 10 items, then lift it might not work well. Yeah. So that's basically. But also notice that here, by default, I just see only 3 metrics. Yeah, there is a way to see more, but this is advanced. So, yeah. And here, this is an empty item set. To get rid of it, you would have to specify the minimum length parameter. So basically, this is just the simple script to run a priori rules method. Yeah. What is this? What's this? Okay, I see. I would need to look into it. Yes, of course. Oh, I see what you mean. I would need to look into how to set the parameters in. I see what you mean. So the question was how to set the parameters so that imbalanced data does not affect the result. Yes, you would need to look at the parameters of the function, right? You would need to look at the help page. Let me see. Yeah, you would need to look at the help page of the function and see if there is any option. Let me see. What was that? What was it? It was in a. Which function did we use? Oh, let's look at this here. Sample. So you would basically need to look at the help page and check. You would need to look at the help page and see if there is an option here. Yeah. Nope. But in general, when you're not sure what the input parameter to the function is, you would type the question mark. You would need to type the question mark and then put the function name, and it's going to show you the help page. And yeah. Oh, see, so that's an option. One option is to do it with replacement. Yeah. One option is to do it with replacement. Yeah. So that could do this. Sampling with replacement could do it. Yeah. So basically the thing about with R is there is more than one way to do something, and every time when I'm not quite sure how to do something, I use help, right? This is my best friend here. And another reason I could use help is that if I want to get fancy plot and I'm not sure how to change the colors, I can look at the help and I can see which parameter changes the color. Yeah. So I hope I at least try to answer the question, but this is an excellent question. And yeah. Okay. So let's see what else. Yeah. And I ran the a priori rules method just because yeah, some of you ask, so I call it customer service, right? So here is basically you can change the minimum support, minimum confidence, and here I can just change, I can say that I don't want to see the rules with item set, I want to have at least 2 items, right? I can do that. Yeah. That basically does. And here I just have this script here is just gonna remove the redundant rules. It's just the method. Right. So what I'm doing here, I'm sorting the rules by list, and then I am running the method to remove the redundant rules. And I'm just plotting the rules, that's all. And there are different visualizations for the rules. But the idea here is that in association rules, there is no class. I don't build the model, right? We cannot just plug in the new instance. But what you could do is what I did here. I specified here to display the rules only if the right-hand side says if the application is approved or not approved. Okay? Yeah. So that's basically, yeah, what I meant, the difference. Let me save this. Okay. So let's see what questions we have. I like questions. But yes, one way to handle if it's imbalanced data set, you can control the sampling with or without replacement. That's one way, I think. Yeah. Let me see questions. Linus, do you have anything to say that I may have missed? Is there anything else anybody wants to ask? Guys, I want you to ask questions. Does anyone have questions? Anybody? Anybody has questions? Guys, I want you to ask questions. This is a very good time to ask questions. Going once? Going twice? Going once? Oh, what is? How can resolve real-world scenario? Oh, what is this? Particularly a lot of... Yes, there is a lot of scanning. Oh, that's right. That's right. So what you would need to do is you would need to well, first of all, there are different methods to prune the redundant rules. And in fact, the data set that we have been working with, a lot of the data sets are actual real. They're from real studies. Like this one, credit card approval data. This is real study. So what you would need to do here, this is what I'm doing. I'm running the code to eliminate the redundant rules. Because if the items in the rule are the subset of another rule, that rule can be eliminated. So you would need to run the logic, like one of the logics is right here. You would be pruning the redundant item sets. And then here you also specifying to look at the rules with a certain frequency. You have to play with these input parameters. See here the parameter list. You would have to identify, yeah. But here the data set is relatively not large, but if you're working with a huge databases, you're probably not going to be running it in a local PC. You're probably going to be doing it on a cloud, right? Because there are applications that have R interface on a cloud. And this is more on a big data analytics class, where you can use R on a cloud. Yeah, and you can use R with database too. Yeah. Yes. Oh yes, exactly. Yes. Yes. And you can use R with databases also. Yes. But we are not covering it into introductory data mining class. This topic is saved for the advanced courses, for advanced data analytics classes. But in the introductory database class, introductory data mining class, what I did was you have a page called RStudio Resources by Topic, and I posted some information on using R with databases, and it's recommended. Well, I just posted it in case you might be interested, but yes, I like these questions. Yeah. For the database, in the database we only do it with a large data set. Yeah. And this is data in big data class. That was one of the assignments that we're gonna do. Is that we have a database on the cloud, DashDB, and we can analyze the data collected from the Twitter, and we can do the association role mining on the tweets. But this is more like a large data set. It's more like a social media mining, so to speak. Yeah. But the data that I'm using right here, right now in these examples, it comes from the real studies. The data is available online, and it is free to use for the educational purposes. It's a statistical data, and it was collected on real studies. Yeah. Yes, sure. Go ahead. I like questions. Go ahead. And just to clarify, guys, so that, yeah. Yeah, go ahead, ask questions. I like questions. So, by now, yeah, why is it important? What? Oh, if I don't set the hidden parameter in neural network, let's see what happens. Then I'm not gonna have any hidden layers, right? I'm gonna lose the purpose. Well, let me see what happens. That's a good question. Let me see what happens if I don't set it. Let me see. What it will do? Either is a default, or is it gonna just, let me see, let me pick something here, right? And let me do this, run. And now let me do this. I'm gonna copy this. I'm gonna copy this. Well, of course, the number of hidden layers is going to affect the errors, and it's going to affect the number of iterations. Okay, let me remove this. I remove it. Let's see what happens. Okay, and now let me do this. It did 1. See this? It did 1. How does it affect the result? Well, the error is going to be different. It affects the result. It affects the network training time. It definitely does. It's just a different error rate, different classification accuracy. You would need different classification accuracy. You would need to compare it. Yes, it does affect the result. But of course, it's going to be different for each data set, but I can do this, and I can do this, and this. So the classification accuracy is going to be different. It's not the same, but again, it's different on each data set. But yeah, but this is a good question. I really liked it because I learned myself that if hidden is omitted, it's going to do 1 by default. It's going to do 1 layer with 1 hidden node by default. Yeah. So some parameters are optional, but if you don't specify them, it's going to take the default values. And of course, the number of hidden layers and the number of nodes in the hidden layer affect the training time. It does affect the training time. Okay? So that's something to keep in mind. Right? And remember to remove the unique identifier. This is an open-ended question. To minimize, well, you would need to. It's a trial and error. There is no correct answer on how to minimize the error rate. You would need to try different number of nodes. It's a trial and error. It's a matter of just trying. What happens if I do this? What happens if I do that? That's what it is. There is no, and again, what works for this data set might not work for the other data set. Yeah, but I like the questions. Those are excellent questions. Basically, and another thing is that when you submit the work for grading, it's not the result that you got, it's how you interpret the result that you got. That's more important. It's how you interpret what you got. Yeah? So do we have more questions? Oh, sure. Yeah, so questions, going once, going twice. All right, I'm gonna stop sharing. And I hope everybody has a nice evening. I'm gonna stop the recording.